Potential energy and force. If we're given a conservative force, we were able to find the potential energy for its system. We're going to illustrate it by using the spring force, and we're not just going to use the simple Hooke's law spring, but let's review Hooke's law for a second. It shows the relationship between the force exerted by a spring on a mass to its displacement. The force exerted by a perfect spring is linear, and that's what we have right here. The force of the spring is minus kx. Not all springs are linear. Okay, this is Hooke's law. And again, what's the negative sign? That means the force is in the opposite direction of the displacement. So we're going to take a spring whose force is equal to minus kx squared. Now, just to save some notation, we'll work with the magnitude of the force, and we will keep the sign, which indicates that the force is opposite the displacement. Let's distinguish between the two forces acting on this spring as it is compressed or expanded. This one here, that's the force done by the spring on the object stretching it. The force exerted by the object on the spring, of course, is the same magnitude and different sign. This is the expression we'll use for calculating the potential energy of the spring. We're going to assume the spring force is a conservative force. And why is it important to make this distinguishing fact between the force exerted by the spring and the external force? What can be derived for a conservative force, which is this guy right here? And if it sounds like I'm being repetitive, I am, just to make sure you get this point. If a system is associated with a conservative force, you can derive a potential energy for it. That's the big point. When calculating this potential energy, you need to use the force from the field, which if you're doing gravity would be the gravitational force, and if you're doing elastic potential energy for a spring, you need the force due to the spring. So that's the negative here. Let's start our problem. Calculate the work done by the spring on an attached object when it is displaced from equilibrium, which is x equals 0, to x final equals x. Then calculate the potential energy, so we're going to relate the potential energy to the work done by the spring, and we're going to calculate the potential energy stored in the system after it is displaced to point x.